Hey, this is OXDF, and today we're looking at day 7 of the 2023 Advent of Code, Camel cards. So basically, we're going to play a game of poker. Um, we're going to get a hand that's going to consist of a string. Let's see, here's like a string like this, and it'll have 2 through 9, and then we're going to have the 10, T for 10, J for Jack, Q for Queen, K for King, A for Ace. The strength of the cards is the standard Ace through King down to 2. And then we have the basic poker hands: five of a kind, five of a kind is the best, then four of a kind, full house, three of a kind, two pair, one pair, high card. And so I get a set of uh, hands and then bids. And what I need to do is I need to sort the hands by strength so that the weakest hand gets place 1, the second weakest hand place 2, the third place 3. Then I need to multiply each bid by its place and sum those up. The only other thing I should say, the tiebreaker, unlike in real poker where the tiebreaker is like if two people have two pairs, the highest card is the tiebreaker. Here it's going to be the order of the cards. So I will say, for example, let's see if I can find both these lines right here have two pairs: kings, sevens, jacks, and tens. So the way you do it is you compare K versus K, tie. K versus 10. This K is more than 10, so this one wins. It doesn't matter, like, the order matters is the point, I guess. And that's it. I think we could do this I think this is one of those cases where we could probably do it faster by like just making a list of tuples where the tuple was the bid and the hand, and then sorting that and making a sorting function. I'm gonna make a class here because I think that's gonna be fun. So let's go ahead and Gen Day 7. That's my script that pulls the input and creates this stub. We can take a look at the input real quick. It's just a lot of poker hands. I don't see anything too exciting. We have 1,000. I also do want to grab the example input to work with. Put that in here. All right, and let's go ahead and write. So, what are we going to do here? We need to think. Okay, so I'm going to make a class, right? So I'm going to do class hand, and we're going to def init. And our hand is going to take in. I could have it take the line, but I'm gonna. Well, all right. Let's have it take the line. And so we will call. We will say. No, I'm gonna have it take hand and bet, and those will both be strings. We're gonna try to do good with our type hinting. We are gonna return none. That's fine. So self.hand equals hand, self.bet equals int bet. And I think we're good there. Well, let's see. What else do we need when we're tracking here? Let's go ahead and get this hand type. Hand type equals, and then I'm gonna make a function to do this just because it'll be easier to figure out. So we'll call self.get hand type of hand. Like that. I guess we don't need that anymore since we can. Okay. Because we already set it in self.hand, so it's available to us. Okay, so what is that function going to look like? Get hand type, and we are going to take self, and that's it, and we are going to return a. I guess let's make this even better. Set hand type. Now we don't need anything. None. And we'll just set it in here. So how are we going to figure out what the hand is? And how are we going to track the hand? I think I'm going to go. This is another place where we could probably just like hack it together, but I'm going to use enums. We'll call this hand type. We need to from enum import int enum. I was actually doing, after reading the description before I started recording, I looked this up. I usually just use enum, but int enum is the same thing, but it's comparable. We can see which one's greater or less than, and that's going to be useful here. So we're going to use an int enum, and all we're going to do here is we're going to say high card equals 1. The next one is one pair. That's what we'll call it. Pair equals 2. 2 pair. See if I can remember the order of the poker hands. And these numbers I'm assigning are arbitrary. I need something to set them as. So after 2 pair comes 3 of a kind equals 4. Then comes two pair, two pair. Full house, I believe. Full house equals 5. 4 of a kind. I could probably abbreviate this or something, but we'll go with it. Equals 6, and then 5 of a kind. They were nice of us. They were nice to eliminate straights and things from us from here. So we just have to worry about numbers of different kinds. So okay, what do we do here? So now for self.getHandType, all we got to do is say we got to look. The way we're going to think about this is we're going to count the number of. We're going to get the counts of each card. Let me just show you. Counts equals self.cards. Hand dot count C for C in self.hand. So we're going to loop, we're going to go over each card in the hand, and we're going to count how many times it shows up. And so, like, if we had 5 of a kind, this would just be 5 5s. If we had 4 of a kind, we have 4 4s and a 1. And it's like kind of sloppy that we're holding extra information there, but like it's perfectly reasonable. So now we can just say if 5 in counts, return hand type 5 of a kind. If 4 in counts, return hand type 4 of a kind. If 3 in counts, return hand type 3 of a kind. Are we going? Did we miss any? Oh, we missed full house, which is better than 3 of a kind. So, well, actually, we need to think about this. Okay, so if 3 is in counts, if 2 in counts, so if there's 3 and 2 both in counts, we're going to return hand type full house. There we go. Otherwise, there's no 2s. We return full 3 of a kind. So let's see. We've got full house, 3 of a kind. So we just have 2 pair, and high card. Let's see. So what we need to do, what does 2 pair look like? We're going to have 2 in there, but we're also going to have another thing that's 2. So we're going to have 4 2s. So if we do if counts count 2 equals 4, return hand type 2 pair. Otherwise, if 2 is in counts, but it's not there 4 times, because we already had that, return hand type pair, and then we'll just return hand type high card. So now we're getting ourselves, oh, and I'm doing return. Shoot. Okay, well, we're going to go back to this. We'll do self.hand type equals self.set. Well, now we're going to change this back to get, and we already never fixed it here, so we're good there. Okay, so now we should be able to make a hand. Let's try that. So now let's come down here and we will hand equal. I'm gonna, because I love doing the one-liners, but because this is gonna be kind of a double loop, I think I'm gonna do it this way. So we'll do for line and lines. Oh, maybe not. Let's see. Well, maybe we might shrink this down in a second. We'll start out this way though. For line and lines, we're gonna say hand equals hand. Let's see. So we're gonna do line dot split, and that'll give us the 2 things. And we'll say hand comma bet equals line dot split, and then we'll say hands dot append hand bet. So we probably could do this in a single. I'm gonna leave it. That's probably more readable. So we're gonna make this list of all of our hands there. And so if we actually do Python -I day7 example, and we do hands, we can't see it. Let's add a repr. So if we come up here, def repr self returns a string, and we're going to do return f hand, and then what is a hand going to look like? I guess we're going to say self.hand. Maybe we can do self.hand type, and maybe self.bet, like that. So if we do that, fill here, come run this again, and run hands. Now we get a nice print of what each of our hands. So we can see we have a hand that is there. Let's see, what is lines? Okay, so we have a hand that is that and that with a It's giving us a 2. Let's see. Can I do .name here? Perfect. Okay. So instead of, I'm going to show the name and not the value. That's fine. So now we have hand. Do lines. The first one here is a pair. What do we have? 2 3s. That's right. Then we have 3 of a kind. 5 5 5. Yep. 2 pairs. Kings and 7s. 2 pairs. Kings and jacks and 10s. And 3 of a kind. 3 queens. Perfect. Okay. So this is looking like I'm happy with how we're parsing. Now what do we want to do? We want to sort this, right? So what we really want to do is we need to find 2 functions to be able to sort a class naturally. We need to find equal, self, other. I think we're supposed to do, this is where, let's see, from typing import self. You can't give it self right here. That doesn't exist yet. You can't give it, I can't say hand right here because actually hand is not defined. It's in the process of being defined. So we give it this self thing and that will work fine. And this will return a bool. And we'll say if self.hand equals other.hand, return self.hand equals other.hand. So 2 hands are equal if their hand is equal. That's basically it. Because otherwise, as soon as the order changes or anything else, they're different. Okay, so now we'll say def greater than self other self, return a bool. And how's this going to work? We'll say if self.hand type equals other.hand type. So then we'll have to do, then we will see, check from start of string. Otherwise, if the hand types are different, we will return self.hand type greater than other.hand type. So this greater than function basically takes self and an other, and then we return if whichever hand type is greater. But if they're equal, we got to check from the start of the string. So we can use string. In theory, what we really should do is create another enum for a card, and then translate our hand into a list of cards. That feels like a lot of work, but we don't need to do it here. So instead, what I'm going to do is I'm just going to create a card map equals. And we can say, so we need to think through, the problem is we have these extra cards, right? The 2 through 9, we could just sort, and because we can compare characters like that, they would just sort, but we can't do that with the next one. So what I'm gonna do is I'm gonna say the 10, I'm gonna just translate that into A. Because A comes, again, if I look at the numbers, if I look at the ASCII characters, let's do this real quick, Python, if I look at the ASCII character 1, is less than the ASCII character 2. That is true. If I show it's greater than 2, that's false. A is actually greater than all the numbers, which works out nicely for us. B is here. I can do B like this. B is not greater than B. C is greater than B. A is not greater than B. So I'm just going to set T to be A. Then the next one is the jack. The 10 becomes A. The jack becomes B. The queen becomes C. The king becomes D, and the ace becomes E. And now with this map, what I can do is I can say, where are we? In greater than, okay. So we'll say self cards equals C for C in self.hand. And what we're really going to do is C.get. Nope, we're not going to do C.get. We're going to do card map.get C. And if C, and then we can give it a default value of C. So that way, if we get a 2, it goes up here, it doesn't get anything, and then it just sets it to 2. If we give it a T, it goes up here and returns A. And so we can do that, and we'll do the same thing here for other cards, and the other hand, and then we can return self cards is greater than other cards. So now we basically map those through, and we should be able to sort them. So let's run this again. We don't need, yeah, let's leave BI here. Hands. So now if we do sorted hands, what do we get? We get a pair, 2 pair, 2 pair, 3 of a kind, 3 of a kind. So that looks good. And then how are we doing by sorting? So this one is KT versus KK. That's correct. Like we're getting larger. And this one is T5, and this one starts with Q. So I think we're looking good here. So now all we have to do is let's see, we want part 1 equal to 0 for hand in hand in, let's see. So we can say for hand in sorted hands, but we also want to enumerate because we need to get the rank. So we can say rank, comma, hand in enumerate sorted hands, and I can actually give enumerate a starting value. So I'm going to give it a starting value of 1 rather than 0 because the first one's going to be 1. Now I can say part 1 plus equals rank times hand.bet. I think we may have solved. 6440. That matches. So let's go up here. Okay, let's get rid of our dash I. And we get a huge number. And it is not right. Let's see. All right. Sorry about that. I stared at this for a while, didn't make much progress, and then I had to take my kids to school. And so I cut the video. I'm jumping back in here. I figured out I feel very confident I know what the problem is. I haven't actually tried it, but right here, we are if 3 in counts, if 2 in counts, hand type full house. Well, we're not returning hand type full house. We're just saying hand type full house. And then we move on and the next line. So every time we have a full house, we're still just going to classify it as a 3 of a kind. And that will cause an error. And we didn't see that in our test data because I don't think there are any 3 of a kinds in the test data. So if we now run this with our input.text, we get a value, we can jump over here, we get it right. Oh, what an annoying error. All right, I'm gonna pause here and read part 2. All right, so in part 2, it's exactly the same, except J's are not jacks, they are jokers, and they are wild, which means I can put, they can be anything. So we need to make some changes. Let's go back to our code. There's a couple ways we could approach this. We could try to like find an optimized hand using the J's. And that would be like, we'd say like, oh, if 5 is in counts, or if 4 in counts and J, or if 3 in counts and 2 J's. But that gets to be kind of a pain. I don't really love that. The other thing we can do is just literally brute force every possible hand, and I think that's what we're going to do. So we're going to make some changes. So first, the other thing we have to change, the card map. J is no longer, J is now the lowest value. So in fact, what I'm going to do here, we're going to grab this. We'll do that first. We're going to put this in here, and we'll do part 2 equals, is a bool equals false by default. And we can say self.cardmap equals that. And if part 2 self.cardmap of J, and we need to give it a value that is the lowest of any values. We haven't used 1 yet, or 0. Let's give it 0. Oops, let's fix that. Equals like that. So now we're going to basically, if we're in part 2, we're rearranging our card map so that J gets the worst possible value. Okay. Now we need to figure out, we need to update this. We're no longer card map before was kind of a static thing, but now we're making it part of it. It's depending on the init. Okay. So what do we do now? We are going to still call get hand type. I'm going to make this different function. Let's see. So get hand type, and we're going to say def get, what are we going to call this? Hand rank. And I'm going to, just for the sake of kind of neatness, let's see. We can make a pass for now. We're going to make this a static method. And a static method is a method within a class, like it belongs in the class, but it doesn't get access to self or the class itself. It's just like a method on its own. We're going to pass in a hand, which will be a string, and we are going to return a list of strings. So all the possible, let's see, no, sorry. We're going to return a hand type. Like that. And get hand type also returns a hand type. We should fix that. And we'll pass for a second. Oh, actually, no. So and then here, this is going to be the same function, like this, except for we just need to get rid of the self now, because now we're just passing in hand and hand. So this should all work. And now we should be able to, if we come here and we just do return get hand, self.get hand rank of self.hand, I believe we should still get the right answer. So we haven't changed anything. We've just put a little shim in here, right? So now what we can do is we can say part 2, and we can call this up here get hand type on part 2, like this. And now we can say if not part 2, boom. So now we should still work. If it's part 2, we're going to need to get the hand type slightly differently. We're going to want to calculate all the possibles. So we're going to make another function here, which will be another at static method def replace wilds. And we'll take a hand, which is a string, and we will return a list of strings like this. Past that for now. We're going to need to import list for our typing. Okay, so now what are we going to do? We're gonna make it. This is actually, I'm going to do this recursively, which I think is kind of cool. We'll say if hand equals nothing, we're going to return the empty string and a list. Otherwise, we're going to return. Let's say what we're going to do. So we're going to do this as a plus b for a in. Now a is either going to be, if a is a j, we want it to be everything. So it's going to be 2, 3, 4, 5, 6, 7, 8, 9. We need 10, queen, king, eighth of all possibilities. If hand sub 0 equals j, else hand sub 0. So basically, a is going to be all of the options in here. And it's either going to, so we're going to loop over either one thing, just the thing, this is the first character, or all these other characters. And then we can do for b in hand.replace wilds hand one that. So what are we doing? Let's try this again. Let's say hand is 5 characters, right? We're going to pass it in here. We're going to, if the first character is a j, we're going to get every possible character plus the rest of the string, plus, actually, let's think of it this way. When hand is 0, we just return an empty list. Great. When hand is 1 character, then this is going to just return, then when hand is 1 character, this is going to be nothing, the empty string. And so we're going to still have the empty string here, and we're going to have, if hand is j, we're going to have all of those things plus the empty string. So we'll have every possible option, single character. But if it's not j, we're just going to have the 1, and then we're going to return that. And then we can do that, so that'll be the return here. So we're building up the string with each character recursively. So we can test this. I can show you just for SI. So if we do hand.replace wilds on 1, 2, 3, 4, 5, we should just get 1, 2, 3, 4, 5. Oop, what do we get? String object has no. Where are we doing a comparison? Hand equals, oh, because I did this. Let's try that. I don't know where hand is defined. Try this again. So we get that. If we put a joker in here, we now get every possibility. So we get 2, 3, 4, 5, 6, all the way up to ace. So this is working nicely for us. Okay, so that means if it is part 2, what are we going to do? We are going to do, let's do h for h in, we're going to loop over all of the hands. So replace wilds on self.hand. And we want to do self.get hand rank on h there. We're going to get the rank. And we need to replace wilds. How do we call replace wilds? Well, we can't call self because, we can call self. Okay, never mind, we're good there. So if we're going to call self.replace wilds here to get all the options, we're going to get the rank on all of them, and we will just do max. And we can do max because we define characteristics and we can return. So that works nicely. The reason we can't do self, this is what, we can't do self here because when we don't pass, a static method doesn't get access to self. And that's why we just pass it, we just call it off the class itself. Awesome. Okay. And so that, I think, is all we need to change. Let's come down here and we can do part 2 equals 0. We're going to have to reparse all the hands. So we'll say hands 2 equals like that. For line in lines. Hand bet equals line dot split. Hands 2 dot append. Hand and bet. And part 2 equals 0 for rank, comma, hand in enumerate sorted hands 2. There's probably a better way to, I probably could, this looks like a lot of repeated code. We could probably clean this up, but we're going to go with it for now because I think I'm hoping it's going to work. Rank times hand dot bet. And let's run that with the example. We get the exact same thing because when we generated the hands, we did not pass in part 2 equals true. Try again. 5905, it actually went down. Is that possible? It is possible. All right. All right, let's run it. And it took half a second to brute force all those things, but not too terribly long. Nice, we got it. Awesome. This was a fun one. And we got to play with enumerate, enums, and static classes or static methods, and defining greater than. And I think there's all sorts of cool class stuff in this one. So hopefully you learned something. I certainly found it interesting, and I'll talk to you tomorrow. Thanks. Bye.